Okay, I kind of want to make this video kind of quick. We've already talked about part of this video before, but just kind of a refresher, and for those of you who haven't watched it before, this is two parts. There's two parts of this video. It's difference of squares, and then you have the perfect square trinomials, which they're going to work together, essentially. Okay, so the difference of squares, your book would define it as a squared minus b squared, which equals, and this is kind of a shortcut, if you see a squared minus b squared, then you know it's going to equal a plus b times a minus b. And the reason this is a shortcut is because if you can memorize this whole thing right here and understand that, it's going to make it easier to factor later. Now, please make a quick note that this only works when when subtracting two perfect squares. If you had a squared plus b squared, okay, then it would not work. But in this case, it's a squared minus b squared. That's why we call it the difference of squares, and it'll work just fine. All right, again, your job on this is just to memorize that highlighted section right there. All right, so let's take a look at what this means. So if you look at this right here, you see a squared plus b squared. Okay, here's a squared. I'm sorry, I said plus, minus b squared. Now, if you look at this, and we said the a squared minus b squared equals a plus b times a minus b. All right, so keep that in your mind as we work through this problem. Now, the first thing I want to do is I want to go ahead and factor like you've been working on in class. Okay, so step one of your factoring process would be to factor out your GCF. Do you have a GCF here? Okay, no, you do not. Nothing. They have nothing in common. So your next step would be to look to see if there's a coefficient in front of the x. Okay, there's no coefficient in front of the x, which is a good thing, which means we don't have to go down a rooftop road. So instead, what we're going to do is we're going to drop our set of parentheses, and we're going to drop another set of parentheses here, and we're going to stick our x in there, and our x in here. And then if you remember, the next step is to look at your L term. Now remember, if you think about this in terms of your standard quadratic form, you have ax squared plus bx plus c. What is missing here? Yeah, your bx term is missing. So what we need to do then is assume that bx, that middle term, which we call the OI term, right, is equal to 0. So now the next step was to look at your L term, which is equal to -9, and find factors of a -9 that equal to 0. Well, the first thing I can think of is -3 plus 3 and positive 3. So -3 times 3 is -9. -3 plus 3 equals 0, right? So then my factors would be x minus 3 and x plus 3. And then that would be my answer. If I FOIL it out to check my work, x times x is x squared. X times 3 is 3x. -3 times x is -3x. And -3 times 3 is -9. Combine your like terms right here in the middle. And these cancel out. So you end up with x squared minus 9. Okay, so that does work, and that proves that that worked. Now, that's the method that I've showed some of you, or some of you have already discovered on your own, is when you have that OI being 0. But if you memorize this up here, okay, and that this is the same, then you'll realize that you don't have to do all that work. So let's take a look again at this. I'm going to draw a little line here. And let's take a look at this again. If we have x squared minus 9, don't we have a squared minus b squared? If that's the case, what is a here? A is equal to x, and what is b equal to? Not 9, but it's equal to 3 because b squared is equal to 9. So that's where that b becomes 3. You're basically taking the square root of that. So if you know a and b, then you can go back to this form up here. Well, you have a plus b times a minus b. A plus b then would be, in this case, would be x plus 3 times x minus 3. And then there's our answer again. A little less work. Because keep in mind, this right here, I would not have done this right here. I would just recognize right away that that's what that is. Okay. All right, let's look at another example. Now, I want to go back for 1 second, actually. If this way right here is best for you and you're comfortable with that, that's fine. Okay, you can do that. This difference of squares just allows us to do this more quickly and factor more quickly, which is really helpful in Algebra 2 when we start to needing to factor before we actually start working on a problem. All right, so let's look here. Do we have a squared minus b squared there? Yeah, what does a equal here? A is equal to n, and b is equal to not 25, but the square root of 25, which is 5, right? So my answer here would be n plus 5, n minus 5. Okay, let's look at another one. And these are the easiest. The first ones are the easiest ones to see. Okay. Do I have a squared plus b or minus b squared here? Yeah. Let's look at a. What is a? A in this case is actually two things: the square root of 36, which is 6, and the square root of x squared, which is x. And b is the square root of 49, which is 7, and the square root of y squared, which is y. So then my answer is going to be a squared, or a minus b, which is 6x minus 7y times a plus b, which is 6x plus 7y. Again, very little to no math at all involved there. And notice it doesn't matter if the minus comes before the plus, because in the first example I did n plus 5, and in the second example I did minus first. It doesn't matter, okay, which one goes first. Okay, and then last, I wanted to show you an example of solving a quadratic using this difference of squares. Do I have a difference of squares here? Yeah. A squared and b squared. A is t, right? And b is 9. Remember, it's not 81. It's the square root of 81, which is 9. So then if I factor this out, I would have I would have t minus 9 times t plus 9 equal to 0, right? If I work this out and solve this quadratic, I would have t minus 9 equals 0, t plus 9 equals 0. And if I solve this out, I add 9 to both sides, I would have t equals 9. And I subtract 9 from both sides, I have t minus 9, or t equals negative 9. And that would be the answer to my quadratic right there. T equals 9 and t equals negative 9. Again, the two things you need to remember is that A has to be a perfect square and B has to be a perfect square. And they have to be subtracting from one another. If they're not subtracting from one another and A is not a perfect square and B is not a perfect square, it's not going to work. So both those things must happen. If you have a perfect square plus a perfect square, there's no such thing as the sum of squares. It doesn't work like that. Okay. All right, one more example. Let's factor this out. Sometimes you have to use multiple steps. So in this case, the first thing we're going to do is do the GCF, right? So number 1 is GCF, which is 5, right? They have a 5 in common. So I factor out a 5, I end up with x cubed plus 3x squared minus 5x minus 15. Okay. Now the next thing I can do, because I have 4 terms already, is group. So now I have 5 times x cubed plus 3x squared times minus negative 5x minus 15. So I've basically grouped those. Now factor out the GCF there. So now I have 5. Okay, here, what do I have in common here? Well, they both have 2 x's, not just one, but 2 x's, so I can take out x squared. When I take out x squared here, I end up with x plus 3, right? And then over here, if I take out a negative 5, I end up with x plus 3, right? If I continue to work this out, I end up with 5x squared minus 5 times x plus 3. Of course, I did factor that 5 out earlier, so I can actually pull that out and actually end up with x squared minus 1 times x plus 3. Okay, since I just factored out that 5 again. Now, am I done right here? Do I have a perfect square? I'm sorry, the difference of squares? Isn't that a difference of squares? Isn't a squared minus b squared? Absolutely. In this case, what is a? A is equal to, again, we're looking at the highlighted thing, x, and b is equal to 1, right? Because isn't 1 squared 1? Yeah, sure is. So take 5 down, and what does this become? X plus 1 times x minus 1 times x plus 3. So there's all of our factors. In this case, we had to do a whole lot of other factoring before we got to that difference of squares, which came in at the end, while we worked out that last thing. Be careful, because a lot of people forget this x squared minus 1, because they forget that 1 is a perfect square. All right. Okay. So we just did the difference of squares, which is going to kind of connect a little bit to perfect square trinomials. Now, again, similar concept as difference of squares as far as a shortcut method, and it makes it a little bit easier to factor. However, I will tell you this, with perfect square trinomials, I usually just go ahead and factor them. I don't usually use this shortcut, but you're more than welcome to if you can memorize it and understand it clearly. So perfect square trinomials are where you have a squared plus 2 times a and b plus b squared, which is same thing as equal to a plus b squared. That would be your factor. This side is where you're actually factored. In this case, you could also have a difference, which you have a squared minus 2ab plus b squared. In this case, if you have a minus right here, you're going to have a minus inside the parentheses, a minus b squared. If you have a plus right here, you're going to have that plus inside the parentheses. When working with the perfect square trinomials, before you just go ahead and do that quick factoring, you have 3 essential questions you got to ask yourself, and they have to be yes to all of these things. Is the first term a perfect square? Okay, so is a perfect square? Yes, it's a perfect square, because the square root of a square would be a. Is the last term a perfect square? Okay, in this case, b squared is a perfect square, because the square root of b squared would be b. And then finally, is the middle term 2 times the square root of the first term and the last term? That's where I usually lose people. Okay, all right, so let's take a look. If you need to pause this, pause it for a second to get all this written down, but let's take a look at an example. Okay, let's say you have this right here. If I factor this, okay, this is what's going to happen. Again, I take out my GCF. Do I have a GCF here? No. Okay, so then my next step would be to determine, does this have a coefficient in front? No, doesn't have a coefficient. That's a good thing. So now I can drop down my parentheses and throw in my, not x's because it's y's this time, throw in my y's. And now I'm going to look at my last term to find factors on my last term that equal my OI. Okay. First thing I think of is 4 times 4. The opposite pair to that would be negative 4 times negative 4. Okay. And then 4 plus 4 equals 8. Negative 4 minus 4 equals negative 8. So I want the negative 8. I'm sorry, I want the positive 8. So this is what I want. So these are my factors. These go away. Okay. So that leaves me with y plus 4 and y plus 4. Anytime you have two factors that are exactly the same like that, the way you write them is say, okay, y plus 4 squared. And that would be our answer. If I wanted to check this, I could just simply FOIL it out. Y times y is y squared. Y times 4 is 4y. 4 times y is 4y. And 4 times 4 is 16. Combine my like terms and end up with y squared plus 8y plus 16. And it does match the initial. Okay, so let's take a look at the next. All right, let's look at the same thing again, but let's use the perfect square trinomial factor. And I'm not going to spend a lot of time on this, so this is going to be the only example that we do on this because it's almost easier just to factor. So y squared plus 8y plus 16. We're going to use the same problem. And we're going to go back to our three essential questions. So the first question is A a perfect square? This is A. Is A a perfect square? Yes, it is. Okay. Is B a perfect square? That's B, remember, in this format. I know it's A, B, C normally in our quadratic form, but in this particular format, this is A plus 2 times A, B plus B. Okay, is B a perfect square? Yes, it is. Because 16 square rooted is 4. And then finally, is this middle term 2 times A times B? Well, if A is equal to Y and B is equal to 4, 2 times Y times 4. Well, 2 times Y is 2Y times 4. 2 times 4 is 8Y. So yes, it is 2 times A times B. So the answer is yes. So you have 3 yeses to your 3 essential questions. That means your answer is going to be something squared. Y, and it's actually B. So it's A plus B. So Y something B. So 4. Okay, squared. Now is it plus or minus? Well, look at that first sign in there. So when we are determining if it's plus or minus, we're looking at this sign here. So it's plus. So then my answer is Y plus 4 squared. And again, I want to point this out. This all here, right here, is mental, and this is mental. So the only work you really would be showing is the answer. So again, that's just a shortcut method. Now, how much easier is it to do that? I mean, it is significantly easier if you can spot those right away. But if you're spending a lot of time asking yourself those questions and those answers, then it kind of defeats the purpose. Okay? Alrighty. So that's perfect. That's the difference of squares and perfect square trinomials. I just wanted to keep it short and sweet, and I will see you guys tomorrow.